Welcome students to my channel Physics Scholar. So here I have come with a fresh new episode, okay, on the chapter light. If you missed my previous episodes, you can subscribe my channel and click the bell icon, okay, to see the new updates coming from this channel, and you can see the previous episodes. So all the episodes I have discussed about the reflection of light and as well as the images formed by the plane mirror and the spherical mirror. So now some numeric sums also will do, but before that we are starting today the refraction of light. Okay, so let us start the chapter. The new topic on light is refraction. So first we have to discuss what is, or you have to understand what is called actually refraction. Okay, reflection already we have discussed. Okay, suppose two mediums are there. And two mediums are transparent. It's not any opaque medium. Okay, opaque medium means the medium to which the light cannot pass or cannot penetrate. Okay, suppose two transparent medium are there. One is suppose air and suppose another is water. One is air and another is water. Okay, two mediums are there. Now, suppose if a ray of light coming from one medium, okay, so if we draw the perpendicular, so what will happen? It will enter to the second medium. Okay, it will enter to the second medium. So this phenomenon is known as the refraction of light. Okay, so all of you have understood what is refraction of light. So if a ray of light coming from one medium enters into another medium, then the direction of the light will change in the second medium. This phenomenon of light is known as refraction of light. Okay, so you see, if this medium is not there, if it is the air medium, so the light travels in straight path, so this should be the direction. But as water is there, that's why the direction change. Okay, so it will bend towards the perpendicular. So we will discuss this later on. Okay, so first you have to understand what is refraction. So when suppose this is air and suppose this is water. Okay, this is water. Suppose from water the light is coming. Okay, and this is the perpendicular drawn. Okay, and so this will be the refraction. Okay, so that means what? When a ray of light coming from one medium enters in another medium, then the direction of the light will change in the second medium. So this is known as the refraction. This phenomenon is known as the refraction of light. Clear? So this angle, the angle of this is the incident ray and this is the perpendicular drawn at the point of incident. So this angle is known as angle of incident. Just like in the reflection, if you recall, so it is known as the angle of incident. And this is what the refracted ray, the angle between the refracted ray and perpendicular drawn on the point of incident is known as angle of refraction. It is known as angle of refraction. So R is known as angle of refraction. Angle of refraction. Okay. So I think all of you have understood what is known as refraction. Clear? So I am explaining once again. If a ray of light coming from one medium enters into another medium, then the phenomenon due to which the direction of the ray changes in the second medium. So this is known as refraction of light. Clear? So this is known as refraction of light. Now let us discuss how the direction will change. What is the rules of the change of directions? What is the rules of change of direction? Okay, rules. Okay, all of you have to remember it. Rules of change of direction. Okay. So suppose it is medium 1 and suppose it is medium 2. Suppose it is air and it is water. Okay, it is air and it is water medium. Clear? So it is what? If we compare the density of the two medium, okay, it is less dense, and it is what? More dense. Okay, the density of water is more than that of air. Clear? So what is the rules? If the ray, suppose the ray is coming from air, so the density of air is less, and this is the perpendicular drawn. So what will happen if the ray of light coming from the denser medium, okay, and coming from or this medium is also known as the rarer. rarer medium. Okay, less dense medium is also known as rarer medium. So if a ray of light coming from a rarer medium and enters into a denser medium, then what it will bend towards the perpendicular drawn at the point of incidence. It will bend towards the, so this should be the direction of light if no medium is there, but due to this medium of water, okay, the refracted ray bends towards the perpendicular. Clear? So if a ray of light coming from a rarer medium enters into the denser medium, then the refracted ray will move towards the perpendicular drawn at the point of incident. Clear? So here what we can say, angle of incident will be greater than angle of refraction. Angle of incident will be greater than angle of refraction. Clear? So if a ray of light coming from a rarer medium enter into a denser medium, then the refracted ray will bend towards the perpendicular, and here the angle of incident will be greater than angle of refraction, or angle of refraction will be less than angle of incident. Okay, so I hope this diagram you can understand. Okay, the light is coming from rarer to denser medium. Now we will discuss in the reverse case. What is the reverse case? You can guess. Now the light is coming from denser medium, enters into the rarer medium. So it is what? It is denser now. It is denser medium. Suppose it is water. It is water and it is rarer medium. Then suppose it is air. The light is coming from water medium. That means denser medium. This is the perpendicular drawn. So it will move away from the perpendicular. Okay. So it is now R and it is now I. So all of you have understood? Just the opposite. When the light is coming from denser medium, enters into a rarer medium, then the refracted ray will move away from the perpendicular. So here what will happen? The angle of incident will be less than angle of refraction. Or we can write angle of refraction will be greater than angle of incident. Clear? So this is the things. Okay. So what are the two rules? When the ray of light coming from a rarer medium enter into a denser medium, then the refracted ray will move towards the perpendicular drawn at the point of incident. And when the ray of light coming from denser medium enters into a rarer medium, then the refracted ray will move away from the perpendicular drawn at the point of incidence. Okay. So these are the two rules of refraction. Okay. Now we will learn the laws of refraction. Okay. Very important for exams also. Laws of refraction. Laws of refraction. Okay. Two laws are there. Already we have discussed the laws of reflection. If you missed, then you can see my previous episodes. You will understand clearly what is the two laws of reflection. And now we will study the laws of refraction. What is the laws of refraction? Okay. Here also two laws are there. Okay. Here also two laws are there. Now I am drawing this diagram. So suppose it is air and it is water. Okay. It is applicable for any two medium where the refraction is taking place. Okay. So what it is then? Rarer, it is denser. So you know that the refracted ray will move towards the perpendicular. Okay. So this should be the original, okay, direction of the light. So when you are drawing the ray diagrams or drawing the diagrams of the light, then always you have to mention the arrowhead from which to which direction light is passing. Otherwise your diagrams will be invalid. Clear? So now laws of refraction. So first law is very similar to the laws of reflection. Okay. So if you can recall. So what are the laws of reflection? This is what ray? This is incident ray. Incident ray. Incident ray. Then what? It is which ray? Refracted ray. refracted ray, and it is what? Perpendicular drawn at the point of incident between two medium will lie on same plane. Okay, see, this is what incident ray, it is what refracted ray, and this is what perpendicular drawn, okay, on the point of incident between two medium. Okay, so this will lie on this is the same plane, it will lie on the same plane. It is very similar to the laws of reflection. You can remember, incident ray, reflected ray, and the perpendicular drawn at the point of incident will all lie on the same plane. Here only in place of in the reflection we are using the term refraction. So incident ray, refracted ray, and the perpendicular drawn at the point of incident between here two medium we are considering. So you have to write the perpendicular drawn between the two medium, all will lie on the same plane. Okay, and second law is different from reflection. Okay, so I know you know the trigonometry. So sine function is there. So trigonometry sine function is there. So if we know sine theta, then what we know in the trigonometry? Okay, perpendicular by hypotenuse, this is a ratio. So the sine theta, okay, is a trigonometric function. So now the so if a ray of light, it is a particular color of light. Okay, if a ray of particular color of light transmitting from one medium and enters into the another medium, then the ratio of the sine of angle of incident to the ratio of the sine of angle of refraction will be a constant. Okay, will be a constant. That means what is the angle of incident? I. So sine I. Okay, sine I divided by sine R is equal to constant. So this constant is derived as a special symbol which is known as mu. Okay, this constant is derived, or it can be denoted by a special symbol which is known as mu. So what you have to write for a particular color of light? Okay, if it is coming from one medium and enters into another medium, then the ratio of sine of angle of incident to the sine of angle of refraction will be constant. Okay, that means sine I by sine R is equal to constant, and that constant is denoted by mu. So that sine I by sine R is equal to mu. Okay, so this mu is also known as refractive index. Refractive index of second medium with respect to first medium. Okay, refractive index of second medium with respect to the first medium, that you have to mention. Only don't write mu is refractive index. Mu because two medium we are considering here. Okay, that's why what is the refractive index? Mu denotes the refractive index of the second medium. That means the medium of air. Okay, the refractive index of second medium with respect to the first medium. Clear? So I am explaining once again the second law. Clear? So if a particular color of light entering from coming from one medium and enters into the another medium, then the ratio, okay, ratio of sine of incident to the ratio of sine of refraction is constant. This constant is derived by mu, okay, or denoted by mu. So sine I by sine R is equal to mu. So mu is also known as refractive index of second medium with respect to the first medium. Clear? So this is the two laws, very important for the exams also. You have to draw these diagrams and you have to write the two laws. I hope you can now easily write this. Okay. So students, in this particular video we have learned what is refraction and what are the rules of how the direction of the light will change coming from rarer to denser or denser to rarer medium entering. Okay, and the two laws of refraction. Okay, first law and the second law. So hope you can understand this topic. If you have any doubt, then you can write it in the comments. Okay, I will try to clarify that. And if you like the video, then share it with your friends or relatives. Okay, so that it may beneficial for them. And also, if you like this, then click on the like buttons also. Okay, so very soon we are coming with the second episode on this chapter.